Look up. For thousands of years, we thought the stars were just lights in a dome. We thought we were the center of everything. But then, we built bigger telescopes. We realized the observable universe doesn't just have stars, it holds over 2 trillion galaxies. They form the cosmic web. A structure so massive, light takes billions of years to cross it. A masterpiece of gravity and dark matter. If you think that's big, brace yourself. Because this entire, mind-blowing expanse? It might just be a tiny speck in a larger sea. Welcome to the multiverse. A hypothesis that suggests our Big Bang wasn't a unique event. It was just one cosmic bubble among infinite others. I know, it sounds like science fiction. But the math keeps pointing us here. To understand why, we have to rewind 13.8 billion years. Back then, everything we've ever observed was compressed into a point smaller than an atom. Then, it rapidly expanded. The Big Bang. Standard Big Bang theory says space expanded, cooled down, and slowly formed the stars we see. But there was a missing puzzle piece. NASA's WMAP data later confirmed a wild idea. In its first fraction of a second, the universe grew exponentially. A phase called cosmic inflation. In 10 to the minus 36 seconds, it doubled in size at least 90 times. Like a grain of sand growing to a galaxy instantly. But physicists Alan Guth and Andre Linde realized a shocking consequence: this rapid inflation mechanism might never actually stop. This is eternal inflation. The underlying space keeps expanding infinitely, constantly creating localized pockets where inflation stops. Those pockets become universes. We live peacefully inside one of these pockets. For us, the Big Bang was just the localized moment our specific bubble settled down and cooled. But outside our borders? An infinite sea of bubbles. Some might have no stars at all. Some might operate with 10 dimensions of gravity. And mathematically, if the multiverse is truly infinite, it means there are infinite exact copies of you. Are you ready to see how that works? To understand how infinite versions of you can exist, we have to stop looking up and start looking down. Way, way down. Before the universe was a universe, it was governed entirely by quantum mechanics. And at the microscopic Planck scale, space is never truly empty. It's a chaotic, boiling soup of energy called quantum foam. Tiny fluctuations pop in and out of existence constantly. This is a proven scientific fact. In 1981, physicist Alan Guth proposed a groundbreaking theory to explain our early universe. He called it cosmic inflation. He hypothesized that a highly energetic, repulsive field caused space itself to expand faster than the speed of light, driven by negative pressure. When this hyperfast expansion happened, it took those microscopic, boiling quantum bubbles and stretched them out to cosmic proportions. In a fraction of a second, random quantum jitters became the massive seeds around which future galaxies would eventually clump together. We know this isn't just a wild guess. The European Space Agency's Planck satellite actually mapped the baby picture of the universe. This is the cosmic microwave background. Those tiny temperature spots? They perfectly match the math of those stretched-out quantum ghosts. But here is where the multiverse theory is born. In our specific patch of space, this hyperexpansion eventually ran out of steam. When the inflation stopped here, all that built-up repulsive energy transformed gracefully into a hot soup of normal matter and radiation. Our Big Bang. But quantum mechanics is driven by probability. Physicist Andre Linde pointed out that this stopping is a random quantum event. While inflation gracefully ended in our little pocket, the mathematical model suggests the overarching background space continues expanding forever. Because the space between the bubbles inflates far faster than light, these separate universes can never reach or touch each other. Welcome to chaotic eternal inflation. A never-ending factory generating an infinite number of Big Bangs. And in an infinite factory. In an infinite factory of universes, do they all look like ours? Do they all have stars, planets, and observers? The short answer is, absolutely not. Our universe is finely tuned. The mass of an electron, the strength of gravity, the speed of light. They are perfectly dialed in for life to exist. If you tweak gravity just a tiny fraction of a percent stronger, stars burn out too fast. A fraction weaker, and matter never clumps together at all. For decades, this fine-tuning problem baffled physicists. Why did our Big Bang produce the exact winning lottery ticket of physics? Enter string theory. String theory is a hypothesis suggesting that particles aren't tiny dots. They are microscopic, vibrating loops of energy. Like the strings of a cosmic violin. Depending on how these strings vibrate, they create different particles. A certain note makes an electron. Another note makes a photon. But there's a catch. For the math of string theory to work, our universe needs extra dimensions. Not just 3D space, but 10 dimensions of space. Where are they? They are curled up, incredibly small, at every point in space. Too tiny for us to ever see or measure. The way these extra dimensions fold determines the fundamental laws of physics. And mathematically, there are about 10 to the power of 500 ways to fold them. That's a 1 with 500 zeros after it. A landscape of possible universes so vast, it makes the number of atoms in our observable universe look microscopic. When you combine the infinite bubble machine of eternal inflation with the 10 to the power of 500 possibilities of string theory, everything changes. Each bubble universe can draw a different set of physical laws. In Universe A, the strong nuclear force is too weak. Atoms instantly fall apart. In Universe B, dark energy is too strong, ripping space apart instantly. Most of these universes are completely dead, sterile, and entirely empty. But if you roll the cosmic dice infinite times, eventually, by pure mathematical chance, one bubble will get the exact perfect settings for chemistry, stars, and biology. The reason our universe seems so finely tuned for us, is simply because we couldn't exist in the dead ones to complain about it. This is the anthropic principle. Let's leave the cosmic lab and enter a mind-bending thought experiment. If our universe is truly infinite in size, we hit a bizarre mathematical wall. Cosmologist Max Tegmark calls this the level 1 multiverse. In an infinitely large space, there are only so many ways you can arrange fundamental particles. Think of it like a deck of cards. You can shuffle it many times, but eventually, if you shuffle an infinite number of times, the exact same order must inevitably repeat. Physically, our observable universe can only hold about 10 to the power of 10 to the power of 115 quantum states. This means if you travel far enough across the infinite cosmos, specifically 10 to the 10 to the 118 meters away, you will hit a mathematical certainty. An exact copy of our observable universe. An exact copy of Earth. And an exact copy of you, watching this exact video right now. But because infinity contains all possibilities, there are also near copies. Universes where you wore a different shirt today. Or made a different career choice. Or, universes where the ancient asteroid gracefully missed Earth, and highly evolved dinosaur astronomers are currently mapping their own cosmic web. Yeah.
Wow.
Let that sink in for a second. An infinite universe guarantees infinite variations of reality. But it gets even stranger. In 1957, physicist Hugh Everett proposed the many worlds interpretation. A completely different kind of multiverse, right here. Everett suggested that quantum mechanics doesn't force a single outcome. Instead, every time a quantum probability occurs, reality literally splits. Remember Schrödinger's thought experiment? According to many worlds, the observer doesn't force the universe to decide. The universe simply creates both versions. In one branch of reality, the journey naturally concludes, and the observer peacefully fades into cosmic mist. In the other branch, the observer continues thriving. This leads to a staggering idea called quantum immortality. Your consciousness can only exist in the branches of reality where you continue to function. Subjectively, from your perspective, you might just experience the universe forever. Shifting from branch to branch, an endless cosmic traveler. Philosophy and thought experiments are wonderful. But physics is a hard science. It requires observable proof. So, how do we test for a multiverse? The problem is our cosmic horizon. We are trapped inside a sphere 93 billion light-years across. Light from beyond that edge simply hasn't reached us yet. Looking outside seems mathematically impossible. Unless, during the early, chaotic moments of eternal inflation, our bubble universe bumped into a neighbor. If two expanding universes gracefully touched, they wouldn't necessarily destroy each other. But the sheer cosmic scale of the interaction would leave a permanent imprint. Like a cosmic fingerprint left on a glass window, this interaction would stretch the fabric of our universe, leaving a distinct, massive circular temperature anomaly. In 2004, NASA's WMAP satellite analyzed the background radiation and found exactly that. A massive, unexplained region known as the CMB cold spot. It's a staggering 1.8 billion light-years across. It is unusually cold and practically devoid of galaxies. Some astrophysicists hypothesize this is the exact point of impact. Is it the first physical evidence of a neighboring universe? Or is it just a massive, natural supervoid, a random cosmic desert? The debate in the scientific community is still raging. But looking up isn't the only way to search. What if we look deeper into the fundamental physics of string theory, right here on Earth? At the Large Hadron Collider in Switzerland, physicists accelerate particles to 99.9% the speed of light, intersecting them to see what the universe is truly made of. If string theory is correct and there are tiny hidden dimensions curled up around us, high-energy collisions could theoretically force some particles to leak out of our 3D space. If we measure the energy before and after the intersection, and find that some energy simply vanished, it might have slipped into a higher dimension. Another massive clue would be the brief creation of microscopic, harmless primordial black holes. Their existence would prove gravity is bleeding across multiple universes. So far, the LHC hasn't found any missing energy or mini black holes. The multiverse remains a profound mathematical ghost. But as Carl Sagan used to say, absence of evidence is not evidence of absence. Our technology is just beginning to scratch the surface of reality. What if the reason we can't find physical proof of other universes is because we're looking in a reality that isn't entirely physical? In 2002, philosopher Nick Bostrom proposed the simulation hypothesis. A mind-bending idea suggesting our entire universe might be running on a cosmic supercomputer. If a highly advanced post-human civilization possesses unimaginable computing power, they could effortlessly run billions of ancestor simulations containing conscious beings like us. Statistically speaking, there would be one base reality and billions of simulated ones. So, mathematically, the odds are heavily against us being the real one. In this scenario, the multiverse isn't a vast ocean of physical bubbles. It's simply a massive server farm, concurrently running infinite versions of cosmic software. But can we test this? Some physicists argue that any simulation would have programmed limits to save processing power. Like a maximum speed limit. Sound familiar? The speed of light is exactly that. It might simply be the absolute maximum rate at which information can be rendered and transmitted in our universe. And just like a digital screen has pixels, our reality might have a minimum resolution. We call it the Planck length, where space becomes grainy. But if living in a cosmic video game is weird, theoretical physics has an even stranger idea that challenges everything: the holographic principle. Pioneered by brilliant physicists like Gerard T. Hooft and Leonard Susskind, this theory actually originated from studying the dark event horizons of black holes. They discovered mathematically that all the 3D information of anything gracefully descending into a black hole is perfectly encoded as 2D data right on its surface. Now, extrapolate that mind-bending math to the entire cosmos. Our rich, three-dimensional reality, with all its stars, planets, and galaxies, might just be a complex projection. A highly convincing 3D hologram generated from a flat, two-dimensional boundary completely surrounding our observable universe. If this is true, the multiverse might just be different layers of 2D code, mathematically projecting infinite layered realities stacked elegantly on top of each other. Simulation, hologram, or physical bubble, the universe gets weirder the deeper we look. But what does this mean for the ultimate fate of it all? Whether our universe is a physical bubble or a holographic projection, one thing is certain: it is governed by time. And time moves forward. So, what happens at the very end of time? Does the multiverse offer a solution to the ultimate cosmic conclusion? Fast forward trillions of years. In our specific bubble, star formation gracefully ceases. The cosmos slowly transitions into what physicists call the Big Freeze. One by one, the last red dwarf stars peacefully dim into quiet cosmic embers. The universe becomes incredibly cold, dark, and lonely. Eventually, even the mighty black holes will slowly dissolve, releasing their remaining energy back into the void through delicate golden Hawking radiation. This process takes an unimaginably long time. About 10 to the power of 100 years. A 1 followed by 100 zeros. A googol. At this point, our bubble universe reaches ultimate thermal equilibrium. Just a vast, endlessly expanding sea of stray photons and fading energy. Absolute stillness. But in 2010, Nobel laureate Sir Roger Penrose proposed a profound hypothesis called conformal cyclic cosmology, completely reimagining this final peaceful state. Penrose realized a mathematical beautiful truth: in a universe containing only massless light particles, the concepts of space and time completely lose their meaning. Without heavy matter to act as a cosmic clock or a ruler, an infinitely vast, cold universe entirely forgets how big it is. Mathematically, the endlessly expanded, cold empty void becomes completely indistinguishable from the infinitely dense, microscopic singularity that started it all. The ultimate end gracefully folds back into the ultimate beginning. Our dying bubble doesn't just fade away, it triggers a brand new radiant burst. A new Big Bang. A beautiful cosmic rebirth. This is the Big Bounce. It means our universe might be just one loop in an infinite chain. Now, zoom back out to the chaotic sea of eternal inflation. Imagine this infinite cyclical dance happening across billions of other magnificent bubble universes. Some bubbles are newly forming. Some are gracefully dimming. And some are beautifully rebounding. The multiverse isn't just infinite in space, it's infinite in time. Long before quantum physics or string theory, humanity instinctively dreamed of the multiverse. In the year 1600, philosopher Giordano Bruno proposed a radical idea. He bravely declared that the stars were other suns, surrounded by their own planets, forming an infinite number of worlds in an infinite void. For daring to imagine a universe larger than human comprehension, he faced severe historical consequences. But over 400 years later, modern astrophysics proves his intuition was spectacularly right. Today, we know our observable universe is 93 billion light-years across. But what about the unobservable part? The space beyond our horizon? According to a 2011 statistical analysis by Oxford University, based on inflation geometry, the true universe is at least 250 times larger than what we can see. And if eternal inflation is correct, it's not just 250 times bigger. It is truly, mathematically infinite. A thought that can trigger intense existential dread. If there are infinite bubble universes, and infinite exact copies of you living out every possible outcome, does anything you do right now even matter? The answer is yes. Even if there are infinite copies of you, this exact version of you, in this exact coordinate of spacetime, is entirely unique in its perspective. You are the universe experiencing itself. And out of 10 to the 500 possible realities, you get to live in the one that is beautifully, perfectly fine-tuned for life. So, the next time you step outside and look up at the night sky, don't just see a dome of distant stars. See it for what it truly might be. A tiny, transparent window looking out into a boiling, infinite sea of creation. A multiverse of endless possibilities, waiting to be discovered. We may be small. We may be just one bubble in an endless storm. But we are awake. And we are figuring it out. Thank you for joining me on this mind-bending journey across the multiverse. I hope it didn't break your brain too much. If you enjoyed exploring the cosmos with me, make sure to hit that like button, subscribe, and ring the bell so you don't miss our next adventure. Until next time, keep looking up, keep asking questions, and always stay curious. See you out there in the void.